As we continue with our geometry lessons, we're going to be talking about linear pairs and vertical angles. And what we want to be able to do is to calculate angle measures using the definitions and theorems about linear pairs and vertical angles, and identify linear pairs and vertical angles from a given diagram, complete the steps to prove statements using linear pairs and vertical angles. And so completing the steps, that's being able to talk through it and provide sound rationale for your decisions. But as we start to look at these things, let's just talk about the definitions and what do they mean. If I look at this diagram right here, if I start pulling some stuff out of here, if I look at ray BA and ray BC on here, so looking at ray BA and ray BC, those are going to be what we call opposite rays, and they are, and why is that important? They form a straight line, and which is 180 degrees. So these two guys are opposite rays. And that is important because that's going to be a characteristic of a linear pair. A linear pair is two adjacent angles whose non-common sides are opposite rays. So if I look at this right here, I have this angle ABD, and then I have angle DBC. And those two are going to be a linear pair because they're two non-adjacent angles. So I have angle ABD, and I have angle BDC, and they're two opposite non-common sides, AB and BC form opposite rays, and that's what makes those a linear pair. Two angles that turn out to have what would appear to be a straight angle or 180 degree angle, two of them. So that is looking at my linear pair. When we talk about vertical angles, that's when we have two intersecting lines. So the opposite angles are formed by these two intersecting lines. So if I look here, I have this line, and they intersect at one point, and they are creating a vertical angle because this angle and this angle are vertical angles, and vertical angles are congruent. They're the same, which they actually create two pairs of vertical angles because I have this angle is also congruent to this angle. So that's what vertical angles are. Angles that are formed by two intersecting lines. So let's see here. Congruent angles. I'm looking over here at my vocabulary words. Congruent angles are angles that are the same. And adjacent angles. Adjacent angles are angles that are right next to each other. So ABD is right next to DBC. They're connected by a common ray, common side. So let's see here as we go forward. Looking to calculate angle measures. Well, I have adjacent angles here. If I look, calculate angle measures. Well, I'm given this angle measure. Let me go ahead and label some stuff. I have angle 1, 2, 3, and 4. Those would be my angle numbers. And learning what we just said, looks like we have two lines that are intersecting at one point, and hopefully we remember that those two lines will form a vertical angle. So the vertical angle are congruent angles. So the vertical angle to 105 here, this angle over here is also going to be 105 degrees because it's a vertical angle, and vertical angles are congruent. I do know too that the other pair of vertical angles are going to be angle 1 and angle 3. I don't know what they are yet though, but if I go back and I remember thinking this straight line is a straight angle which is 180 degrees. So if I wanted to figure that one out, I know that angle TRV plus angle VRW is equal to 180 degrees. Or angle 1 plus angle 2 is equal to 180 degrees. I don't know what angle 1 is yet, but I do know that angle 2 is 105 degrees, and that is going to be equal to 180 degrees. So just do my inverse operations, and I end up with 75 degrees. Angle 1 is equal to 75 degrees. Well, if angle 1 is equal to 75 degrees, then hopefully you see that its vertical angle right here is going to be angle 3. So angle 3 is also going to be equal to 75 degrees. And that's calculating angle measure, just using some of the vocabulary that we've been learning. Two-column proof. Better come back to that. Okay, so as we work on a two-column proof, what they do is they give you a little information, and then you fill in the blanks of using the principles and definitions that you've learned. So and it will be a two-column proof of statements and the reasons why. Sometimes you have to come up with a statement. Sometimes you have to come up with the reason. Usually the first thing that will always happen will be given. So completing a two-column proof, it says fill in the blanks to complete the two-column proof of the linear pair theorem. Given angle 1 and angle 2 form a linear pair, okay? So angle 1 and angle 2 form a linear pair, and then prove that angle 1 and angle 2 are supplementary, okay? So first, if I look here, statements, angle 1 and angle 2 form a linear pair. That is my given right there. So that is going to be given. Next, if I look at, I have ray BC and ray BA form a line. So I have ray BA form going that direction and ray BC going that direction. So that looks like opposite rays, and part of the definition of a linear pair was that it had opposite rays. So we can call that the definition of a linear pair, because a linear pair were defined by opposite rays. Okay, now when it tells me that the measurement of angle ABC is equal to 180 degrees, what we do know is that when we have a definition of a linear pair, when we have opposite rays, right? Opposite rays form a straight angle. A straight angle is going to be 180 degrees. So then my reason for step 3 is going to be the definition of a straight angle. Because if they're opposite rays, they form a straight angle, and therefore they're equal to 180 degrees. Next, using the angle, somehow I'm going to do something that provides a reason that I use the angle addition postulate. Well, if the angle addition postulate, what would that be? Goodness. Well, if I have angle ABC is equal to 180 degrees, angle ABC is equal to 180 degrees, then I know that angle 1 plus angle 2 is going to be equal to angle ABC. So I would have angle 1 plus angle 2 is going to be equal to 180 degrees. And then if I have, or angle 1 and angle 2 is going to be equal to angle ABC. Now, there we have the substitution of if I have the measurement of ABC is equal to 180 degrees and angle 1 and angle 2 are equal to the measurement of ABC, therefore angle 1 plus angle 2 are equal to 180 degrees. So there we go. And that was using substitution. And let's see what is next. It says angle 1 and angle 2 are supplementary, and I think they are supplementary because that is the definition of supplementary angles. Definition of supplementary angles are they are equal to 180 degrees, and that is completing a two-column proof. Normally, we'll get better at it, but we're always just using the stuff that we've learned, and the first one is always going to be a given. That's what we're looking for. And then we just step through the process to figure out what defines what. And that is working in a nutshell with first attempts at a two-column proof, but working with vertical angles and linear pairs with some of the characteristics of opposite rays, identifying straight angles, and all of this stuff just keeps coming back and working together. So as we continue to work with it, we'll become more familiar, but don't hesitate to stop and review the video and make sure it clarifies, or make sure you're posting questions if you have them. Finding unknown angle measures in linear pairs. Okay, what do I know? Let's see. I know that in this example it says, what is the value of x? So I want to find the value of x. The value of x. But what I do know is, just looking at this picture, is I have two lines that are intersecting at a given point. So we should be able to turn around and say, well, this angle right here is equal to this angle right here. These are congruent, right? And then these two angles are congruent. So if that's the case, then this angle equals this angle. So it looks like angle SRT is congruent or equal to angle VRW. And doing some substitution, well, I know that this angle is going to be x plus 40 is going to be equal to 3x. Do some inverse operations, and I'm going to subtract x from both sides. That gives me 2x is equal to 40, divide by my coefficient, and then x is going to be equal to 20. So if x is equal to 20, that's what they wanted us to find out. So there's my answer. Now if I wanted to find out what is this angle going to be, well, I just simply say 3 times 20 is equal to 60 degrees. And if I check it, this angle right here is going to be x plus 40, which is going to be 20 plus 40, and that is going to be equal to 60 degrees. And sure enough, those two things are congruent. So it looks like when I check it, it's good. So that's just using, again, vertical angles and a little bit of math. And finding unknown values, unknown angle measures in these linear pairs. And what is the measure of TRV? The measure of TRV. So they want us to find that angle measure, right? What is the degrees? And it did mention linear pairs, but what do I know? I know that SRT plus TRV, okay, those are adjacent angles because they're right next to each other. And I should hopefully be able to pick out that angle SRT plus angle TRV is going to be equal to something. Well, if they are linear pairs, they have opposite rays. Hopefully you guys know that they are going to be equal to 180 degrees. They're supplementary because of this straight line right here. It's a straight angle. So if that's the case, then I can turn around and do some substitution. I know that SRT is equal to x minus 10 degrees plus angle TRV is going to be equal to 2x plus 10 degrees. And those are both added together going to be equal to 180 degrees. So now I can just do my combining like terms and solve for my variable. So that if I combine my variables, I have x plus 2x, and then I have negative 10 plus 10. So that ends up giving me 3x plus 0, or 3x is equal to 180 degrees. Divide by my coefficient, and then x is going to be equal to 60 degrees. Okay, well, I found out my unknown, but they didn't ask me to find out what x was equal to. They asked me to find out what is the measure of angle TRV. Well, TRV right here, so TRV is going to be equal to 2x plus 10 is equal to 2 times 60, because we said it was going to be x is equal to 60 plus 10, so that would give me 120 plus 10, or 130. So angle TRV is equal to 130 degrees. 130. So there is, using those definitions and a little bit of algebra, we're able to find the angle measures of those linear pairs.